Welcome to our review on electromagnetic waves. What we're going to consider first of all then is something that hopefully you've done as an experiment at some point in your past in science, where you start off with a little ray box and then you have a single ray of light shining through a glass or plastic prism, and on the other side you see all the colours in the visible spectrum, so the red, orange, yellow, green, blue, indigo, violet. Now, what we're actually looking at there is just one little section of this larger entity called the electromagnetic spectrum. So you can see visible light right there in the middle. But that's just one of the 7 different regions we need to know about. So what you need to be able to do with this, not only recall the names of the 7 different types of wave that we have on our EM spectrum, but you also need to know about the correct order for them. So that if they were to ask you to place them in order of increasing wavelength or increasing frequency, you could do this. So if we start off first of all with the longest wavelength or the lowest frequency, we start with our radio waves. And then if we move through the increasing frequency, we go to microwaves, then infrared, visible light in the middle, then we go to ultraviolet, X-rays, and then gamma rays. Hopefully what you can see is that as the frequency is increasing, the wavelength is decreasing. So if we consider what we're talking about when we refer to these electromagnetic waves, quite simply they consist of oscillating electric and magnetic fields. And these fields are going to oscillate at 90 degrees to the direction that the wave is travelling in. So if you look at the diagram at the bottom there, you can see that our wave is travelling from left to right on the screen. The electric field, which is the one in red, is at 90 degrees to the direction going above and below. And then the blue one represents our magnetic field, which is kind of going into the screen and coming out towards us, if you like. Again at 90 degrees, just in a different plane. One of the key things that we need to know about our electromagnetic waves is their velocity. Now, all electromagnetic waves will travel through a vacuum at the exact same velocity, which is 3.0 times 10 to the power 8 meters per second. Now, that coincidentally is, of course, the speed of light, because as visible light is part of our electromagnetic spectrum, and all electromagnetic waves travel at that same velocity, therefore it must be the speed of light. There are also some other words we should be aware of here. So the first one is when we're talking about a source, that is something that emits electromagnetic waves. So for example, we might have a microwave oven emitting a microwave, therefore it's a source. We've also got other objects that are capable of absorbing electromagnetic waves, and a good example here is the skin, which is able to absorb infrared to heat up. But we also find that electromagnetic waves transfer energy from those sources to the absorbers. So just make sure you're aware of those different terms and how they can be used. Now they can ask you to carry out calculations to do with electromagnetic waves, but the key thing here is what they're not going to give you in the question. So we already know from our earlier bit of work in P5 that we've got to know the wave velocity equation, so frequency times wavelength. But you also need to know the velocity at which electromagnetic waves travel, which is our 3.0 times 10 to the power 8 meters per second. So the kind of question they could give you is here. The sun emits ultraviolet waves with a wavelength of 320 nanometers. Calculate their frequency. So they're expecting you to know the wave velocity of an EM wave and to know the wave velocity equation. So the first thing you're going to do with that is write down what you know. Write down your equation that hopefully you've already learnt, write down the wavelength they've given us there of 320 nanometers, and write down the wave velocity, which hopefully you've retained as 3.0 times 10 to the power 8 meters per second. Second thing we need to do is we need to convert to our standard units. Nanometers are not the standard units of wavelength, remember, that should be in meters. So when we convert our 320 nanometers into meters, we end up with 3.20 times 10 to the power minus 7 meters. Which then just leaves us with our last bit, which is to substitute into our equation and to solve it. So because we're calculating the frequency, obviously we need to rearrange it first of all. So that will give us wave velocity divided by wavelength. Substitute in our values that we have worked out or we know, so 3.0 times 10 to the power 8 divided by 3.20 times 10 to the power minus 7 gives us our answer of 9.4 times 10 to the power 14. And remember, because we've worked out a frequency, that has the unit Hertz, which is our capital H, lowercase z. Hopefully at the end of this video you can now describe what electromagnetic waves actually are and what they do. You can describe the main groupings of the EM spectrum and how they're different in terms of their frequency and their wavelength. You can state the electromagnetic waves that our eyes detect, and you can also recall and apply the relationship between speed, frequency and wavelength for our EM waves.